Hello, I am Suman Jain, and I am presenting a generalized framework for legacy system modernization to the cloud. So here we start with outline. First, we would go for cloud computing concepts and basic characteristics of cloud computing. Then why legacy systems should be moved to the cloud and what will be the advantages for cloud computing for the legacy systems. A basic cloud computing model contains a large pool of all the computing resources and services which are shared by millions of users over a communication network. Basic characteristics of cloud computing include measured service, which is based upon a pay-per-use model, rapid elasticity, a pool of resources, broad network access, and on-demand self-service. There are three basic delivery models. First is software as a service. It is to consume already existing applications in the cloud. Then there is platform as a service, which we use to build and deploy new applications within the configurable programming environment. And later, we use infrastructure as a service to host the developed applications with full control over the programming environment. Can cloud computing help legacy systems? Yes, as legacy systems are those existing systems which may be built on some outdated platform or older programming languages which may not be in use currently. Still, these systems remain valuable for the organization. Cloud computing helps them to focus more on new technologies and innovations. There is major cost cutting of infrastructure setup and installation cost due to cloud computing. Also, legacy systems are expanded to a wider range of customers. Along with cloud computing strategies, there may be possibility to add some parallel processing approaches for those legacy applications which may be using sequential implementation or may be processing very large data sets. Google's MapReduce framework and its open source counterpart Hadoop are the main approaches to realize parallel computing in the cloud. Let's move on to modernization framework. We'll start with some old legacy system, and in decision making module, first we have to assess our source application. We have to decide whether single component or there are multiple components which are to be migrated on the cloud. Then the application complexity is analyzed. After that, on the layered architecture of application, there are application layer, data layer, and business layer. Which layer we have to target for cloud migration is also decided. There are some quality of a service such as non-functional attributes which are to be kept in mind while migrating the source application to the cloud. First is performance. We have certain performance matrices such as data processing time, execution time, or any running time of algorithm. Then we have to compute the multi-tenancy among all the applications, and there should be enough security principles for the migration process. After that, in the similar way, target cloud environment is also assessed. We have to decide which service model among software as a service, platform as a service, and infrastructure as a service we have to go for. And then which deployment model as public, private, or any hybrid cloud we are going to follow. Then the particular cloud vendor is selected according to the pricing policy he has been it is offering. After decision making module, we have to select what kind of suitable approach we should follow for modernization. There are four basic approaches. First is replacement, which can be either full or partial according to the application. Next, we can wrap the application with some new web interface. Then we can re-engineer the application, which includes refactoring, modification, and redevelopment of the code. Then finally, there is migration to the cloud. Migration also comprises of migration to the software as a service, platform as a service, and infrastructure as a service. When we have selected a particular modernization approach, we have to install and configure the environment for it. Then we have to modify some part of the code on incremental basis. Then we migrate the data and the application both to the cloud. Also, there is an important step to test the execution of that particular part in the cloud for the performance analysis. We have to follow this cycle incrementally until we have migrated the whole application to the cloud. So, the conclusion is a generalized approach is presented for the assessment and decision making module for source and target environments, and it elaborates all the existing approaches whether cloud is included in or not. Also, to optimize the cost and resources, parallel processing techniques are also implemented. For that case study, a best fit memory allocation application has been realized on Amazon Web Services using MapReduce. Thank you.